Alright, let's do this problem. This is from AS Physics exam of May of 2023, I believe. So what do we have? We have two liquids, P and Q, in an open tube, in an open column, and they don't mix. And the liquids are in equilibrium, so it means they don't move around. And given that, we are looking for density of P to density of Q, this ratio. That's what we're looking for. So, where shall we start? We shall start here in this condition, equilibrium. So what does it mean? That means the liquid doesn't move around. In other words, the force acting down here, for example, must be identical. So that also implies the pressure at this point must be equal to the pressure at this point. So where does the pressure come from? At this point. The pressure at this point is come from this liquid because it's pushing down, and on top of it, atmospheric pressure pushing down on the whole thing. On the other hand, at this point, where does the pressure come from? Pressures come from this liquid, this column, and atmospheric pressure. So that means, since atmospheric pressure on two sides are identical, pressure coming from this height of liquid must be identical to this one. So if you take a look, obviously this one is twice the height of this one. So that also implies the pressure, the density of liquid P must be half the density of Q. So density of P is half the density of Q. So that means our correct answer at this point would be that one. So that would be it. But just for completeness, let's do the calculation explicitly. So to do that, we have to choose 2 points. Here, let's call it point A, and point here, let's call it point B. And then we will write the pressure expression at point A being density of P, G, gravitational constant, times the height of the liquid, which is 2x, plus atmospheric pressure coming from here. So the same thing we can do for the other one. Alright, here it is. And these two must be identical. That's the condition. So that means the pressures at point A and B are equal to each other. If we write it and equate the two pressures, that's what we will get. Obviously, these terms would be cancelled out. And also we can say, well, skipping over and doing some cancelling, we can do that, this. So that leaves us with twice the P equals Q. So what we're looking for is rho P over rho Q. That would be equals to here. So here's your answer. Alright, so that's it. Happy solving.